merging operations performed? Merging operations are performed by choosing any one node from both the trees, connecting them with an edge. In that case, the entire both the trees are connected, and this is called as a merging of two trees. Now, merging should be performed such that the diameter should be minimum. Now, the first thing is you should be knowing what a diameter is. Although they have defined the diameter, it is simply the it is diameter of a tree is the length of the longest path between any two nodes in the tree. So for you, the diameter after this tree is merged, that diameter should be as minimum as possible. Now, diameter problem is a very important problem. I had already taught you, and this one is the harder version of finding the diameter of a problem, because here the tree is a binary tree. I will highly recommend go and watch this one video. But for a quick recap, what we did in this video is we found the max left depth, max right depth, and that is a good candidate to pass on to your parent. Again, either one of them will be a good candidate to pass to your parent. For example, in this case, I will go and find my max left depth, max right depth. Okay, right depth is maximum, so this is something which means right depth is something which I will pass on to my parent. But at this point, at every point, I will be finding the diameter of my tree. How? Again, max left depth, max right depth. As you can see, max left depth is something which I passed on to my parent, so I can get that left depth from my child. Right depth I'm calculating itself, but that too should be my max right depth and plus one for me as a node, and thus I will get the diameter at this current node, which will help me to maximize my diameter, because I will find the diameter at every node. Now, think these are the two things which are primarily important. Pass something to your parent. Pass what? Pass one of the things, either the left depth or the right depth, because in this case I am passing my right depth to my parent, and thus my parent was able to find its diameter and try to maximize the global diameter. Okay, but this was the case. Again, in this video, I taught you all the approaches from brute force, better, optimal. Please go and watch this video. Now, if you remember in the beginning, I taught you this is a harder version of finding the diameter. The easier version is just getting the crux out. The crux was for any specific node, the diameter, the maximum diameter can be max left depth and max right depth. So for any node, the diameter can be max left depth and max right depth. So in that case, what you can simply do is go and find the left depth, or you can just say go and find the node having the maximum depth. Go and find the node having the maximum depth. Okay, this is, let's say, the node having the maximum depth. But from where is a question. Okay, I will answer the question from where. But let's say you went on and find the node having the maximum depth. From this first node, you will again go and find some other node having the maximum distance from this first extreme node. So I will name this as a first extreme node. Next one will be second extreme node. For that second extreme node, I will simply, again, when I say extreme, which means it is at the extreme distance from the already extreme node. So imagine that one of the extreme depths you have achieved from the first extreme node, and the other extreme depth you have achieved from the second extreme node, and thus this will be your diameter. Now the question for you, like the question which you might have wondering is, Aryan, this strategy looks easy, thus why you did not apply in this problem? Because it was a binary tree, or to be more precise, it was a tree which is built like pointers, which means that if, let's say, anyhow I reach to this node first, I cannot go up to my parent. I cannot start traversing from this node. There is no connection from the child to the parent. Even if there is, I will have to maintain somehow, I will have to make another data structure or another memory which will do this. But for our current problem, it is graph based, which means you are simply given the edges, which means it is your responsibility to build the undirected graph. Thus, it will be easy for you to traverse from this first node and go to the next extreme node. Now, summarizing, how will you find the diameter in such cases where you are given the graph? It is that you can start from any node, go and find the first extreme node. Again, extreme node is defined having the maximum distance. So I went on and found the first extreme node. When this first extreme node is found, as you can see, this will be extreme node because all the other nodes are at a smaller distance from this node. So starting from this node, I went on and checked which node has the extreme distance. That is the candidate for first extreme node. Now, if this is the first extreme node, go and find the second extreme node, because from first to second, that will be your distance. So I will start my traversal simple. Either it can be a DFS or a BFS traversal. I will start my traversal from this first extreme node and will try to look for my other extreme end and name it as, let's say, second extreme node. Thus, distance between first and second will be my diameter. Diameter, as you can again read, it is the longest path between any two nodes. And considering the same concept, I was trying to look for left extreme, right extreme. In this case, I just thought, okay, find one of the extremes and then from that one extreme, go and look for the other extremes. That will be my diameter, or the distance, maximum distance between any two nodes of my entire tree. Now the question will be, Aryan, you started from this node. What if I would have started from this node? Okay, if you would have started from this node, then the first extreme end would have been this. This was the first extreme end, and then this would have been second extreme end. Okay, then you might ask, Aryan, what if I would have started from, let's say, in mid, which means here? Okay, no worries, as you can still see that this is 1, 1, 1, 2, 2, 2, and then 3, 3, and then 4. So this will again be the first extreme end, and again from here I would have went on and did a traversal to find the second extreme end. If you were wondering what I did right now, 1, 1, 2, 2, here I was just trying to do a simple BFS just so as to find the max distance node, or you can do a simple DFS also. You just need the node having the maximum distance and the node number. That's it. So we realized we can simply find the diameter. But Aryan, the question was something else. You don't have to find the diameter, you have to minimize the diameter. Okay, so what is okay? Give me the answer. The answer is, okay, for this case the diameter would have been 2. So the maximum distance for this tree would have been 2. In this case, the diameter is 1. Diameter is 1. Now, if I would have asked you, you have to maximize the diameter, then you would have done one thing. Just connect the two extreme nodes of both the trees. Let's say this is the first extreme node, this is the second extreme node. This is the first extreme node, this is the second extreme node. To maximize the diameter, you would have connected the two extreme nodes. That's the answer, right? But now in this case, imagining, like, again, let's say I make it a different tree, just a big one, just to make you like feel it. You feel it. So in this case, as you can simply see, diameter is 1, 2, 3, 4, 5. Diameter is 5. In this case, diameter 1, 2, 3, 4. Diameter is 4. So just to maximize the diameter in total, you would have connected these two extreme nodes, and you would have achieved a diameter of 9. 5 plus 4 plus this one, which is 10, sorry. So now your task is to minimize the diameter. So obviously you will try to not put the extreme ends, and reversely going, how we try to achieve the maximum diameter reversely, just so as to not get maximum, I want minimum. So I will try to put mid of both the trees. So to find the diameter, which was the maximum distance, I was trying the extreme ends, but now to minimize that, I'm trying the mid, so that I will, again, what will happen because of this? 1, 2, 1, 2, 3. So here the distance will be 3. Here the distance will be 1. Here the distance will be 2. Thus, the diameter of the merged tree will be 3 plus 1, 4 plus 2, 6, which is 6. Thus, it's a simple greedy technique in which I thought that diameter would give me maximum, but earlier I would have attached the maximum, like extreme ends, to achieve the maximum diameter. But now I want the minimum diameter of the merged tree, so I will choose the mid of both the trees diameter, and thus they will return me the minimum possible distance. Simply, and everything generated because of the concept of diameter which we learned in this video, how we reach to a diameter. Now simply what we will do, we will simply see, okay, the diameter for this is a 2, the diameter for this is 1. Simply I will connect my this with a this. So here the diameter which will be impact, again let's see the bridges. So if the diameter was a 2, I'm roughly breaking at the mid, so it will be diameter as 1. I'm adding a 1, that's one edge I'm making, and then here in this case you will see, Aryan, when the edges were odd, as you can see here, still the diameter is 1. The diameter is still a 1. As you can also remember, in this case also the diameter was a 5, but still one end will give you a diameter of a 3, other end will give you a diameter of 2. So you want the actual diameter of the merged tree will be 3 plus 1 plus 2. In this case, when the D was 4, it was 2 and a 2. So you realized when the diameter is odd for one of the tree, you have to take the seal value of half. So I have to take the seal value, which means D by 2 seal I have to take. I can also take a D by 2 seal here also, because 4 by 2 seal is again a 2. But 5 by 2 seal value is again a 3. So I will achieve a 3, which means half. Again, seal is a half, plus 1 to make one edge, and then again a seal value for diameter of 2 by 2, which will give me a 2. So answer is 3 plus 1 plus 2, which is 6. Now to represent the seal value in the code, you will see that I have represented my seal value by simply saying D plus 1 by 2. It is the same way representing D by 2 seal value. Cool. Now coming on back, oh, you got the answer that for this 1 plus 1 by 2, which means 1 by 2 seal value is 1. So diameter will be 1 plus 1 and plus 1. So diameter will be 3, which is the minimum diameter I can achieve. For maximizing, the answer would have been, I would have put at the extreme ends. Cool. Let's say for the same example, here the diameter, if I just go and find 1, 2, 3, 4, the diameter here is 4. Again, we can simply find this diameter by starting from any node, go and find the first extreme node, then starting the DFS from the first extreme node, go and find the other extreme node, that is the second extreme node. That is your answer. Cool. Now with this, you will find diameter, which is, let's say, 4. Here also in this case, you will find the diameter. Here also the diameter is 4. Now you will have to merge those two. So I'll simply merge those two. Answer will be simply 2. D by 2 plus D by 2 plus 1. Plus 1 for this one. Cool. Answer is 5. Now, you might say, Aryan, it looks very simple, that what I will do, I will start coding in which I will find the diameter of my first tree. How I will find it? I will start my DFS from any node, go and find the first extreme node. Extreme node is defined by having the maximum distance. Then from that first extreme node, I will go and find the second extreme node, which will give me the second extreme node itself. Thus the distance between both of them will be the actual diameter. Same way, I will find the diameter for the other tree, which means this tree. And when I have both the diameters, I will do a D by 2 seal value. D by 2 seal value of the diameter number 2, and then add a plus 1, and that's my answer. I will say partially. You will pass nearly your test cases except a few, because you missed one thing. What? For this example, let's see. The diameter in this case is 1, 2, 3, 4, 5, 6, and 7. Diameter here is 7. Okay. Diameter here is 1, 2. Okay, diameter here is 2. Now, it feels evident that what I will do, okay, 1, 2, 3, which is 1, 2, 3, 4, 5, 6, 7. So I have to take a mid. Mid I will take, let's say, as 1, 2, 3, 4. Okay, I'll take the mid as here, and then I'll put it here because it is 1 and 2. So if I take the mid from here, the distance, this distance will be the distance which will be contributed as d by 2, which means 7 by 2 seal value, which is 4. It is seal value, which is 4. Again here, it will be the diameter 2, which impacted will be 2 by 2 seal value, which is 1. So technically, the merged tree diameter should be 4 plus 1 plus 1. It should be 4 plus 1 plus 1, which is 6. So are you saying, Aryan, that the merged tree diameter is 6? I will say the impact of merging is 6, not the merged tree diameter is 6. Because why? That's a very big statement. Because when you merge these two trees, because of merging, the diameter impact, which means the new diameter which can come out to be, it can come out to be 6. But this tree already had a diameter of 7. So the merged tree will always be bounded by the maximum diameter. So what I am telling you right now is, because of merging, I did not increase the diameter. The diameter of this entire, again, the diameter of this tree was 7. The diameter of this tree was a 2. On merging of this tree, I was able to achieve, because of the merging, I was able to achieve the diameter 6, which means the impact was of 6. But still, because of diameter of this tree being 7, the entire merged tree will also be having a diameter of 7. Because of this branch, it will have diameter of 7 itself. And thus, when I will have to find the answer, my answer will be diameter of 1, this diameter of 1, the diameter of 2, let's forget this. So diameter of 1, comma diameter of 2, and because the impact of merging, which is seal value of diameter of 1 by 2 plus seal value of diameter of 2 by 2 plus 1. Maximum of these will be my minimum diameter after merging this tree. Cool. Let's see the code. Now, firstly, we have to make a graph out of these edges. So I will make the graph out of these edges. How I will make it? Simply, I called a graph function, which will make me adjacency list out of these edges. And I received in graph 1 and graph 2. So let's see. It's simply iterate on all the edges and simply make a graph. As you can see, I know it is a tree. Tree has n minus 1 edges, considering I have n nodes. So if I have n edges, I will have n plus 1 number of nodes. That is the reason I made my graph of size n plus 1. Then I simply made an undirected graph, and I simply returned my graph. This is function which is making my graph. Now when this graph is made, my task is to find my diameter, or I can say diameter of both the trees. For that, I told you there are two things. First thing is, let's say if you have a tree, if you have, let's say okay, let's go to the back tree only. Let's say if you have this tree, the first simple task is choose any random node, go and find the first extreme node from this random node. This is the first extreme node. Now when you have this first extreme node, go and find the second extreme node from the first extreme node. And this will be your diameter. And the entire concept is just based on this only, that we go and find the max depths. Now coming on back. So what we will do, we will simply have, again, I have taken, I'll explain you my code. I've taken my result and this result. This says that I will have to go and find my first extreme node. And then for the second case, this is when I will start my DFS from any node, I will have to go and find the first extreme node. That is, in this case, I should know what the node is, because the next time I have to start my DFS from this first node. But in the next iteration, I just need to know I don't need to know what my second extreme node is. I just need to know this distance, because this is actually my diameter. So you can roughly see that I need node also and distance also. So it's the reason I have taken both of them. I have taken my distance also and node also. That this is a distance, extreme distance, and this is a node to which that extreme distance is. So firstly, ignore this. Let's say firstly I will start my DFS from any random node. Here I took the random node as node 0. Parent is -1, and so far the distance from the starting node is 0. This is the distance. This is the distance. And I passed in the graph, and this is my result variable, which will change, and this will give me my first extreme node. First extreme node this will give. How? This is simply having a function in which I pass in the node, I pass in the parent, I pass in the distance from my root node from where I started. In this case, I started from 0 itself, and right now my distance from 0 is also 0. Then I passed in my graph, and then I passed in my result. Result contains a distance and the node having that maximum distance. Firstly, in the very beginning itself, the current distance, if it is more than my maximum distance with my result, I should update my result by saying that this is the so far maximum distance, and this is a node containing that maximum distance. Then I'll simply do a DFS in which I will go and call, as I know it's a simple tree, so I will not be having any cycles or stuff. So I'm good to only refer my parent. If you think it's a graph or stuff, then you can also have a visited array. Then I will simply go and call my neighbor, passing my self node as my parent, and the distance because of this will increase by +1, and then passing the same resultant graph. With this first, what will happen? With this first, what will happen? You started your DFS from node 0. Then you will be achieving your result. Your result will have the first extreme node, or you can say you will have your first extreme node. This result will contain distance, and node, and this will be your first extreme node having the maximum distance. Now, when you have received the first extreme node, which is result.second, is the first extreme node, I will pass in my result.second in my another DFS call. Parent is -1. The distance from the first extreme node is 0. Graph and result 2. Now this will help me to find the second extreme node. Again, the same function call. This will now go and find me, again the same thing, go and find me the second extreme node. Now in this case, my result 2 has my second extreme node, but I'm more concerned about result 2's distance, because result 2's distance, which means result 2 has two things, distance and node. Here the node represents the second extreme node, but this distance represents distance from first extreme node to second extreme node. This is this distance. So I will just put this distance as my diameter of first tree. I will repeat the exact same process for my second tree. And thus I have achieved diameter 1 and diameter 2, and thus my answer is maximum of diameter 1, diameter 2, and seal of diameter 1 by 2, diameter 2 by 2 plus 1, which means the impact of merging of both the trees, and thus this is my minimum possible diameter of merging of both the trees. Cool. And again, time, because of you are simple doing a DFS every time, it is time of O of n. You did DFS 4 times, right? Time is O of n. Space also because you are using adjacency list, you are still making the graph and stuff. So apart from making your graph and stuff, you are simply traversing the entire tree. So yeah, it's still a space of O of n itself. Cool. I hope you guys got it, and see you guys in today in the live stream. Bye bye. Take care. Forget it. I was referring like to join Discord and LinkedIn. Bye bye.